Hey guys, in this video we will be understanding the meaning of moments, or so you can feel what moments actually mean. So let's see, and you can actually understand how it would be useful in your daily life. Let's see. Um, if this is a doorknob here, let's see, this is a doorknob here. And let's say this distance is ideally, let's say this is just 10 centimeters simply, and this is the fixed point in your doorknob. This becomes your pivot because this does not move, and you would have noticed that this does not move. So if you apply a force in this direction, let's say 100 newtons to turn the knob, let's see what the moments tell you about the turning. Moments, the moments are given by F force times distance, which is the perpendicular distance. So your moments is 100 times 10 centimeters, which becomes, since the distance is 10 centimeters, and we always use the perpendicular distance, you can see that these two will make a 90 degrees. So this is 10 centimeters, which becomes 0.1 meters. So your moment is 10 Newton meter. This means that the turning effect is 10 Newton meters. So just remember this result, and we'll continue doing some more things here with the same problem. So let's say I decide to turn the same door handle from closer to the pivot. Let's say from here with the same force, 100 newtons. I'm applying the same force, but I'm trying to turn it from here. So what is the distance? Let's say the distance here becomes 6 centimeters. Now if I find out the moment, it's simply force times distance. The force is the same, 100 times 6 centimeters, which is 0.06 meters. This becomes 6 Newton meters. Now you can see I was applying the same force, but the turning effect was lesser than earlier, which was 10 earlier. Let's see if I, on the same thing, let me just change the color here. If I apply it from here and with the same force, 100 newtons, let me find out, let's say this is the distance, let's say 2 centimeters. If I simply just use the formula to find out the turning effect of this 100 Newton force from this distance, simply be 100 times 2 centimeters, or 0.02 meters. So moment is 100 times 0.02 meters, and moment would be 2 Newton meters. So for the same force, there would be very much less turning than it was earlier. So as we're going closer to the door, as in doorknob, to the fixed pivot, the same force is having lesser turning effect, which is making it more difficult to turn the doorknob. So you can see that this is, if I applied it from here, it was 10 Newton meter. If I applied it from here, it was 6. If I applied it from here, it was 2. This means the same force has lesser turning effect as I'm moving closer to the knob, or to the pivot. So let me give you some more things, so you know why there is this thing attached, why we do not move it from here. That is because it's difficult moving it from here comparatively. That is why we attach this thing, so that we can apply a force here. So the closer you apply your force to the pivot, the more difficult it gets. Try opening a door. So that is why we have this thing, so that it makes it easier. Let's see one more example. You all must have come across a bolt, let's say, something like this. Something like this. Something like this. Just say this is something like this. And you have to turn it around, all right, to loosen it up. Let's say this is a bolt, something like this. All right. And you have to turn it like this to loosen it. All right, it will turn and turn and turn, and it will come out. Let's say it's around a long rod here. This is a rod and it's fixed here. This round bolt is fixed here. Let's see, if I have to turn it directly from here, what do we usually do? In these cases, we use a spanner. What happens? A spanner is a device like this. What happens? Let's see. If this was the bolt originally, and this is the pivot because this is the fixed point of the bolt, and for the entire system, this is the fixed point. Let's see, if I move it from here, the distance from the pivot is almost 0. But if I use a spanner and I apply a force here, 100 newtons, there is this huge distance. Let's see, now imagine I have this long spanner and I have this shorter spanner, or I'll show you. Let's see, I have a longer spanner and this distance is, say, let's just say 0.5 meters. So if I want to find out the moment of this force, this would give me, this is force times distance, the perpendicular distance from the pivot, from the center, and moment is given by 100 times 0.5. This gives me 50 Newton per meter. This is 50 Newton meter. However, if I use a shorter spanner, let's say this is my shorter spanner, and so this is a shorter spanner, and I'm using this to turn this around, and I'm applying the same force, 100 newtons. This distance is 0.25 meters from the pivot. You would see that if I find the moment, I would get 100 times 0.25, which is 25 Newton per meter. This means that the same force would give me lesser turning effect, and it would make it difficult for me to turn it around compared to a longer spanner. And if I need to have the same moment, I will have to double the force. Let's see, for this shorter spanner, if I use a 200 newtons, if I apply 200 newtons here on the shorter spanner, then in that case, my moment or the turning effect, this is 200, the force that I am applying, and this is the distance, which is 0.25, again because it's a shorter spanner. Then in that case, this would give me 50 newtons meter. So you can see that when we were using a longer spanner, we were able to turn it with a moment, or with a force of 100 newtons, we were able to give it a turning effect of 50 newtons per meter. However, when we were using a shorter spanner, we had to give a force of 200 newtons. We had to push more to give the same turning effect. So that is why we use longer spanners when we are turning a bolt. That is theory. That is the physics behind it. So always remember, whatever you're doing, there is always some physics involved here. So I hope you understood this concept and you understood the application of this concept. And if there are any queries, just write them down and I'll be replying to them. So thanks for watching, guys, and we'll meet in the next video.